Okay, dividing polynomials. So you have a polynomial, 1, 2, 3, polynomial with 4 terms, and you're going to divide it by x plus 2. So the long division looks like this. So you take x cubed minus x squared minus 14x plus 24, and you're going to divide that by x plus 2. This is just a binomial. There's 2 terms. So you can work it out, long division, find the quotient, and maybe there's a remainder. Maybe there's some left over or not. So what they want you to do here is only focus on the remainder. They don't want you to worry about actually even dividing it out the long way. They want you to use the shortcut. So they want you to find the remainder by evaluating the function at a minus 2. So depending on what this is right here, if you're dividing by x plus 2, we are going to evaluate the function at a minus 2. If you were dividing by x minus 2, then we would evaluate the function at f of a positive 2. So these are kind of always opposite. So if this is a plus 2, this is a minus 2, this is a minus 2, this is a plus 2. So here's how the shortcut works. Since we're dividing by x plus 2, I am going to evaluate the function at a negative 2. So this is function notation. So here's your function right here. So your function is equal to x cubed minus x squared minus 14x plus 24. Okay, now we did these, maybe it's first quarter. So into the function, you're going to evaluate a minus 2. So instead of the x, you're going to replace all those x's with a minus 2. So wherever there's an x, let's put parentheses. So instead of the x, let's put a minus 2 cubed, subtract, give the x, put parentheses, put a minus 2 squared, subtract 14 times x, so it's going to be 14 times parentheses, put a minus 2 plus 24. Okay, now this is just a calculator move. Type all that in exactly like you have it. You have to have the parentheses because there's a big difference between parentheses minus 2, well, mostly the even ones, this guy right here, minus 2 squared or any even power versus a minus 2 squared. Because if you do not have the parentheses, you're not including the negative. So this one, you're going to square both the negative and the 2, so it's actually a minus 2 times a minus 2, and that gives you a positive 4. But this one right here, if you don't include the parentheses, that is only influencing the 2. So you actually have a minus out front, and then you have 2 times 2, and that gives you a minus 4. So one of them gives you a positive 4, one of them gives you a minus 4, and that's going to mess you up if you need to be ending up with a positive 4. So the parentheses are a big deal. So if you type all that in, a negative 2 cubed, that cleans up to be a negative 8. And a negative 2 squared ends up to be a positive 4. But then you got this negative right here, so it's negative 4. So you got a negative 8, negative 4. A negative 14 times a negative 2 is a positive 28. And then a positive 24. So you got a minus 8 minus 4 plus 28 plus 24. Okay, you end up with 40. So your remainder is 40. Number 2 is similar. So given that f at a negative 8 is going to give you 0, what are all the factors of the following function? So this right here, 0, is my remainder. So that means there's not a remainder. So that means it goes imperfectly. So I'm going to take this polynomial, which was x cubed plus 14x squared plus 57x plus 72. So kind of in a fancy way, they're telling you the remainder's 0. They actually want you to find this. They want you to figure out, if you divide it, what does it equal? So now, if they plugged in a -8 into all these x's, -8 there, -8 there, -8 there, and they got 0, that must mean they're dividing by x plus 8. So, we're going to divide this by x plus 8. Now we got to work it out long division. So you only kind of worry about the x. Let's look at the x and the x cubed. So what are you going to times x by to turn it into a cube? And that should be just a x squared. Okay, now I got to distribute. I got to times the x squared to the x, and that gives me x cubed, times the x squared to the 8. That gives me 8x squared. Okay, now your move is you have to subtract. You got to subtract that, and you have to subtract that. So these will zero out, and these 14 squares take away 8 squares. Should give you 6 squares. Then bring down your next term. So bring down 57x, and then kind of start over. What can you times x by to turn it into 6x squared? And that is 6x. So 6x times x gives you the 6x squared. And then the 6x times the 8 gives you 48x. Okay, now you gotta subtract. So that's a 0. 57, take away 48, gives you 9. Okay, bring down the next term, which is 72. And what are you going to times x by to turn it into 9x? And that is a 9. 9 times x gives you 9x. 9 times 8 gives you 72. And you've got to subtract. And it looks like he was right. That's a 0, that's a 0. So the remainder is 0. It goes in perfectly. So your factors, that's what's going to times together. So this guy right here, the x plus 8, is going to times this guy right here, x squared plus 6x plus 9. If I times those together, it's going to give me this x cubed plus 14x squared plus 57x. Okay, now this guy, actually, you can factor this down even further. So I'm going to copy paste my x plus 6 or x plus 8. Okay, this one is going to be actually pretty easy because it starts with 1. So how do they times and get x squared? It's just going to be x. And then how do they times and get 9? But add and get 6, and it should just be 3 and 3. 3 times 3 is 9, 3 plus 3 is 6, so this one matches up best with C. Okay, now sequences and series. So arithmetic sequences, they grow by addition. And the model for an arithmetic sequence is just, it's linear, so y equals mx plus b. Okay, now you gotta kind of understand the lingo. So a sub 20 for a -1, 2, 5, and they want you to find the indicated term. So this is actually the 20th term. They want the 20th number in this list. So the pattern looks like it is just plus 3 from here to here, plus 3. So the next one would be 8, the next one would be 11, then 14, and so on and so forth. They want you to find the 20th. So we kind of organize it into a table, and the first, the second, the third, the fourth, the fifth, and so on all the way. They want the 20th. So the first is going to give you a -1, the second gives you 2, the third gives you 5, the fourth gives you 8, And you can use the model to skip around real fast. So you can just add 3 and figure it out yourself, or you can use the model to skip ahead. So the model, you just need to find 2 things: how fast it's changing, the m, and where it started at 0. So the m is going to be 3, the b is where it started at 0, and it's not shown in the table, so you got to go back 1. And if this is up 3, up 3, up 3, to go backwards you go -3. So this should be a -4. So b is a -4. Now here's what you got. You've got an equation. Take 3, plug it in for m, take -4, plug it in for b, and you should have y equals 3 times whatever x is -4. So this formula will give you all the y's and x's that you want. And I want the 20th x. So I'm going to take 20 and I'm going to sub it right here in place of x. So you should do 3 times 20, and that is 60 minus 4. So the 20th one is going to be 56. Okay, the second one looks a little different. So they want a sub 1 is 1, d is 6, n is 17. Okay, d, that's the same thing as m. And this a sub 1 is actually your first. So this one is talking about the first, the second, third, fourth. So the first one is this guy right here. So this one is the first number in the pattern. And if it's growing by 6, so this one's going to be 7, this one's going to be 13, this one's going to be 19. Because that's your slope right there. So it's growing by 6, up 6, up 6, up 6. Except for 7 plus 6. Yeah, that's 13. Okay. Now, they want you to skip around. This is the end. They want you to find the 17th number in that list. So the 17th number. So it's kind of the same as last time. You either add 6 17 times or 16 times, or you can skip and do the formula. So the formula, I need 0. 0, if I go back 6, should be a -5. So my formula is y equals 6 times the x, then -5. And I want the 17th x. So y equals 6 times 17 minus 5. Whoops, 6 times 17, 102 minus 5. So that is 97. So your 17th one is going to be a 97. Okay, let's look at the geometric sequences. So geometric, they grow by multiplication. So the model for the geometric is a sub n equals a sub 1 times r to the x minus 1. So this is the end. That's the same thing as y. Y equals the first number in your list times by r. That's the ratio which it's grown. So kind of like your rate at which it's grown, what you're times it by. X minus 1. So you can kind of do the same thing. You make a table. And let's see if we can make sense of these. A sub 1, that's your first one. Your first one is a -3. Your second one, r is what you're going to times by. So you're going to times this by 2. So that's going to be -6. 3 times that by 2, it's going to be -12. So you're just doubling it every time. And they want you to find the 13th number in the list. So you're going to skip, 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 find the 13th. So again, the formula is probably easy, or you just times by 2, times by 2, times by 2. I'm going to keep track of how many times you do that. So a sub 1, we're going to go y equals, instead of a sub 1, we're going to put -3. times r, and in place of r we're going to put 2, and then we are going to go x minus 1. Okay, now you cannot times these together, because if you times these together, that means it's going to be a negative 6 to the x minus 1, and that means you're timesing every time by 6, and you're not. You're timesing every time by 2, so do not ever times these together. You've got to do, please excuse my dear Aunt Sally, you have to do exponents first. So you have to do the exponents first before you can do the times. So I want the 13th x. So I'm going to take 13 and I'm going to plug it in right there. So the y is going to be a negative 3 times 2 to the 13 minus 1, and that is equal to a negative 3 times 2 to the 12. And that's what you type in on your calculator. So negative 3 times 2 to the 12, and that should equal y equals a negative 12,288. Okay, the next one, same thing, it's going to be geometric, so we're going to use the same model. This is actually my first, my second, my third, and my fourth, and they want you to find the 12th. So you either, looks like it's just doubling, so that means we found our r equals 2, which is the same r as before, so it's doubling. Your a sub 1 equals 0.5, and that's all we need. So your formula is going to be y equals a sub 1, 0.5 times 2 to the x minus 1. And we want the 12th, so let's take 12 and plug it in there. Y equals 0.5 times 2 to the 12 minus 1, that's 11. So punch that in, 0.5 times 2 to the 11. So the 12th number in your list should be 1024. Okay, now we're going to do a sum of the arithmetic series. So if you add them all up, the sequence turns into a series. So the sum of an arithmetic sequence is found by a formula where we do the very first element in the list plus the very last. So we add those together first, and then we times it by how many numbers are in the list. So the total number of terms cut in half. So you fold the line. So you take the very first plus the very last. 1 plus 43. And they always give you the same number. So this one is changing by 3. So that means this one should be a 40. So you do 4 plus 40. Fold the line. 4 plus 40. That also gives you 44. 7 plus 30. What is it? 37. That gives you 44. So the question is, how many of these 44s are there going to be? So you find the total number of terms in the list and you divide it by 2 because you're pairing them up. So it's the number of pairs. So that's your formula. Make sure you have that in your notes handy for the test. Okay, here's the problem. We can do the first plus the last. 1 plus 43. We know that's going to be 44 times. This is the question. How many numbers are in that list? And you can use the model to find it. You can use y equals mx plus b. And that will give you your x and your y. So we know that the first, the second, the third, we know the first is 1, the second is 4, the third is 7. And what we don't know, the last one is 43. Which happens to be, this time it happens to be a y. I want to know what its corresponding x is. And I can find m and b pretty easy. M is 3, so b happens at 0. B is a minus 2. So your model is going to be y equals 3x minus 2. And the 43 is actually your y, so I'm going to put 43 in place of the y. So it's going to be 43 equals 3x minus 2. Now you just solve for x. So undo the minus 2, plus 2, plus 2. You should have 45 equals 3x. Undo the 3. So divide by 3, and if you divide by 3, 45 divided by 3 is 15. So that means 43 is the 15th number in that sequence. So the total number of terms is 15. Divide that by 2. Doesn't divide by 2. It's like 7.5. So we're going to do 44 times 7.5. So 44 times 7.5, and that is equal to 330. So if I add all those up, it should give me 330. Okay, the next one is kind of in sigma notation. So this one is totally different than this one. It gives you actually the mx plus b. So there's my formula. And they want you to start by plugging in 3 for n. So you're going to plug in 3. If you plug in 3, it's going to be 10 plus 6. So that is 16. Then you're going to plug in 4. So it's going to be 10 plus 8. And that is 18. Then you're going to plug in 5. So it's 10 plus 10. And that's 20. So you keep going until you plug in 18. So it's going to be 10 plus 2 times 18. And 2 times 18 is 36. And 36 plus 10. Okay. So that's what I end on. So my formula, the first is 16. The last is 46. And I times that by how many numbers are in the list. And you went all the way from 3 to 18. So you plugged in a 3. This was 3. This was 4. This was 5. This was 18. So you actually, if you subtract 18 minus 3, that's 15. But it's not 15. It's actually 16. Because you're going to include the 3. The difference between 18 and 3 is 15 spaces, but I'm going to include the 3. So if you count on your fingers, it might be easier. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So count on your fingers, include 3, and you should get 16. And then you cut that in half. So 16 plus 46 is 62. And you're going to times that by 8. So 62 times by 8. Those should add and give you 496. Okay, one more. So geometric sequence. Oh, they want the equation. So the equation is just y equals the first one times the r to the x minus 1. So that's the first one. If you organize it into a table, sometimes that's easier. The first one is a minus 2. The second one's a minus 6. The third one's a minus 18. Okay, so that's a sub 1. Now look at it and you got to figure out how it's growing. It's growing by times 3 times 3. And that is actually the r. So your formula is y equals the first one minus 2 times what you times by the ratio, 3 to the x minus 1, And that's it. Okay. Okay, so your binomial theorem. The binomial theorem, if you use your Pascal's triangle, is not too bad. So if you expand this out 5 times, that's a lot of distributing, and it's going to get large super quick. So the shortcut is to use Pascal's triangle. So you're going to go to row 5 on Pascal's triangle. So row 5, you got to make sure you have that on your notes. 1, 2, 3, 4, 5. Okay, now your numbers. You copy the numbers from row 5, and it's a 1, 5, 10, 10, 5, 1. Okay, now you start with your x's, but your x also has a 3. So I'm going to go times, it's all times. Okay, now it's subtract. So this is actually going to be subtract plus subtract plus subtract. So your signs are going to alternate. Okay, so now you're going to do 3x, and you're going to do 3 to the 5th times x to the 5th. And you're going to times 3 to the 4th times x to the 4th. And you're going to times 3 cubed times x cubed times 3 squared times x squared times 3 to the 1 times x1. And the last one, there's zeros, so we don't need them. And then you start from the right and work your way left with the second one. So it's going to be times 4 to the 5th y to the 5th. So times 4 to the 4th y to the 4th times 4 cubed y cubed times 4 squared y squared times 4 1 y1, and then there's going to be no y's on the left, on that far left one, because they're going to be zeros, and anything to the 0 is just 1. So now you've got to clean it up. So on my calculator, you just do 3 to the 5th, and that cleans up to be 243x to the 5th. Now I'm going to do minus. Now on your calculator, do the numbers. You got to do 5 times 3 to the 4th times 4. And that is 1,620. And then do your letters. You've got x to the 4, y1. Okay. Now do your numbers. 10 times 3 cubed times 4 squared. 10 times 3 cubed times 4 squared should give you 4,320. Then your letters, you've got x cubed y squared. Okay, now your numbers. Let's do minus 10 times 3 squared times 4 cubed, and that gives you 5,760, and your letters are x squared y cubed. Okay, now 5 times 3 times 4 to the 4th, and that's 3,840. X to the 1, y to the 4th, and your last one is just a minus 1 times 4 to the 5th, and that is 1,024, and your variable is just a y to the 5th. And that is your answer. So 1, 2, 3, 4, 5, 6 terms. That's a big old ugly polynomial. So Pascal's triangle makes it pretty slick. Okay, then we spend some time with logs. So let's do a few logs. Now, condense these to a single log, so we actually have 3 logs. And they're all log 6, log 6, log 6. So first, as you scan these, this number out front is the exponent of the 2. So take that there, and you can turn all 3 of these logs into one single log. And if you're adding, addition is related to multiplication. So you're going to take this guy times this guy times this guy, which is 2 cubed. And that's your answer. Leave it just like that. Don't times those up. Okay, this one, anytime you got a number out front, take it. That is the exponent of the u. This 6 is the exponent of the v. So it should be log base 4 of u to the 30. Subtract log base 4 of v to the 6. And subtract is linked with division. So turn these 2 logs into one log. It's going to be log and base 4 of u to the 30 divide v to the 6. And leave it just like that. Okay, now we're going to go backwards. We're going to take one single log and expand it into several logs. So multiplication is linked with addition. So it's going to be log and base 4 of 8 plus log and base 4 of 5 plus log and base 4 of 3 cubed. But you got to go one more step. This one's not done. You've got to take the exponent and put it out front. So it's going to be 3 times log and base 4 of 3 plus these other 2 guys. Okay, this one. First you've got to square the parentheses. So take that to that and take it to that. So it is going to be log and base 2. On top, it's going to be 10 to the 6. If you already have an exponent and you raise it to another level, you times them. So on bottom, it's just going to be 11 squared. Okay, now division is subtraction. So this is going to be log and base 2 of 10 to the 6, subtract log and base 2 of 11 squared. Then take your exponents out in front. So this is going to be 6 times log and base 2 of 10 minus 2 times log and base 2 of 11. And that is where you stop. Okay, now equations with logs. Let's do this one, and let's use the rule we just did. Let's combine these 2 logs into a single log. So log base 9, and even on this side is log base 9, so the logs are all in base 9, which is nice. Now, if you're adding them and you want to rewrite 2 logs into a single log, let's go log base 9 of this portion of minus 4x times this portion times 7. So it's going to be log and base 9 of a minus 28x. And on the other side, we got log base 9 of 112. Okay, now we're kind of going to do a mental math thing. So you're going to solve an equation. The left side has to equal the right side. And this portion equals this portion. So I'm going to kind of ignore them. And I'm going to make sure that this portion of minus 28x is equal to this portion, 112. So now, just undo the multiplication. Divide by a negative 28, divide by a negative 28, and you got x equals 112 divided by a negative 28, so x equals negative 4. The next one is not quite as easy, but we're going to start off with the same. So we're going to take those two logs and we're going to turn them into one single log. So log base 9, I'm going to go log base 9, and minus is divide, so it's going to be this part, x minus 9 divide this part, and that's equal to 2. Okay, now I'm kind of stuck, because if the left side equals the right side, the left side is a log, but the right side is not a log. So I've got to solve for x. I've got to undo the minus 9, I've got to undo the divide 6, and I've got to undo the log in base 9. And the only way you can undo a log is to morph it to an exponent. So if you take this log and you express it as an exponent, there's going to be a base, there's going to be an exponent, and there's going to be what it equals. So kind of three portions. 9 is the base, 2 is the exponent, and this mess, x minus 9 over 6, is what it equals. So now we can simplify it. 9 squared is 81, is equal to x minus 9 divided 6. So now undo the divide 6, times this by 6, times this by 6. So we got 81 times 6. 486 equals x minus 9 plus 9 plus 9. Final answer, x equals 495. Okay, the third one, you got to solve for r. So these top two were given to you in logarithmic form, and these bottom two are given to you in exponential form. So you got to remember, to undo logs, you use exponents. To undo exponents, you use logs. They're inverse of each other. So solve for r. Ditch this minus 4. So let's plus 4 to both sides. And you should have 18 to the r plus 4 equals 54. Now you gotta ditch the 4, but you gotta ditch the 18 first. And the 18 is actually a base. And the only way you can undo a base is a log. So we're gonna do just the opposite. We're gonna morph it to a log. So there's gonna be three parts. The base, which is 18. The exponent is always what it equals. It's a log equals the exponent. So this is r plus 4, and then the 54 goes here. Okay, now this part most likely is going to be some crazy decimal, and your calculator needs to find out what the decimal is. So just punch it on your calculator. Log base 18 of 54, and that decimal is 1.38093 blah 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 equals r plus 4. So minus 4 minus 4. So if you do that number minus 4, r actually equals a negative 2.619906, and so on and so forth. Okay, the next one, the fourth one, solve for b. So undo this minus 10 first. So let's plus 10 to both sides. And you should have e to the 5b equals 24. And then you got to undo the e. So the only way to undo a base is a log. So it's going to be log base e of 24 equals the exponent, which is 5b. Do this on your calculator, log base e of 24. Hit enter, and then divide that by 5. Divide whatever that decimal is by 5. And you should get b is equal to like 3.178-ish, somewhere around there.